Hey everybody, we are going to talk today about linear equations. We are in Algebra 2, Section 2.2. All right, so our vocabulary requires us to remember a little bit about linear equations from last year. So linear equation, one definition is to think of a linear equation as an equation in x, y, that when I graph it, I'm going to get a line. Hence the word linear here, and you see the line in linear, right? So examples of linear equations would be like y equals 2x plus 3. And we saw a linear equation, at least one in the last section, or sometimes 3x plus 2y equals 7. Lines in this form. In fact, linear equations have certain forms, and we'll talk about it. A linear function is the same as a linear equation, except it will be written in the form of f of x is equal to. So generally it will have a y equals kind of pattern where instead of y, we'd have f of x is equal to, let's say 2x plus 3, or f of x is equal to some other value, negative 1/2 x minus 7, something like that. Standard form, an example of standard form is this right here, where x and y are both on one side and a constant is on the other. Specifically, standard form is ax plus by equals c, where a, b, and c are elements of the integers. All right, so they're all integers. I think in our text they use the kind of German z for integers, and I forget what integers is in Germany, what the word is, but I think it's a z. I'm going to use a capital I. That looks a little bit weird though, okay? All right, so they all have to be integers, and specifically a has to be positive. A has to be greater than 0. So that's standard form. So once the x, the term next to the x, the coefficient of x is positive, and all of these guys are whole numbers, you have it in standard form if it's in this way. Y-intercept. So let's take a look at a graph really quickly. If I have an XY graph or graphing plane, and I were to, let me get a different color, graph this line, say the line did something like that, right? The y-intercept is where the line hits the y-axis. So the y-intercept, this guy here, is right here. It's where the line hits the y-axis. I'll draw a little ghostly yellow arrow there. And the x-intercept, let's use maybe green, is where the line hits the x-axis, right here. Now, to talk a little bit more about what point that is, I'm going to use a solid color. So when I'm talking about the y-intercept is going to be the y value of the equation when x is equal to 0. Because notice where it's located. This point is exactly where x is equal to 0. And so the y value will be the y-intercept. Similarly, where the blue graph hits the x-axis is considered the x-intercept, and so we call that the value of x, literally it's the point x0, the value of x when y is 0. So these are a couple of different ways of referring to the x-intercept. We can talk about it as the location, or we can talk about it as the point where x-intercept, where y is equal to 0 and x is equal to the x-intercept. And the y-intercept is the point where x is equal to 0 and y is the intercept. All right, I hope that was clear. Okay, so this first example is going to require us to determine whether we have a linear function or not. And so what I'd like you to do is recall that, so we have that form ax plus by equals c, which we talked about as standard form. We also have y equals mx plus b. So anytime you have an equation that will be in these two forms, anytime you have an equation, you know automatically that it's a linear equation. There's a couple other properties of linear equations that we should note. X and y are to the first power, right? The equation themselves would be considered first degree equations. We talked a little bit about degrees last year. So let's go ahead and look at our examples and see if we can kind of make some sense out of it. I'm going to leave that over there. So here I have f of x is equal to 10 minus 5x. Well, we know that f of x is another way of saying y. So I could write this equation as y is equal to 10 minus 5x, right? And then it's a matter of just order. I can move the 5x this way, and that's a plus 10. And we can see clearly that y equals negative 5x plus 10, which is equivalent to this function right here, this linear function. We can see that this is definitely in this form, y equals mx plus b. So we know that, yes, we have a linear function. Let's look at the next one. So yes, this is a linear function. That's what that refers to. And this guy over here, get this out of the way. So this is g of x is equal to x to the 4th power minus 5. Already there's a problem. If you remember last time we talked about degree, degree is what we do is we go to the variables in the equation and we see how many variables in a sense are bunched together at one time, and that tells me the degree. So this is a 4th degree function, and no, this is definitely not linear. So it's not linear because of that 4th degree business there. Not linear here. This is, first of all, this notation might look weird to you. H of x, xy, what? This is a function in 2 variables. So technically this is a function in 3 variables. Like this is like y is, well not y, right? Because I can't use y. This is like z is equal to 2xy, right? Because remember h of xy or g of x or f of x is just the replacement of a variable. So if I'm replacing a variable, it can't be x and y, so it's got to be something else. Already that's a problem. Let's say you weren't tipped off by this. Let's say, so it's not linear, but let's say you weren't tipped off by that. Look at this xy. Technically, this is 1 to degree 1, and this is degree 1 together. This is degree 2 because it's all being multiplied. So this is a 2nd degree equation for our intents and purposes right now. This is leaning more towards 2nd degree, though this is not even this is like in 3 dimensions, so we ain't gonna talk about that right now. All right, so this is what we have going on, 2nd degree, so this is also not linear. All right, so remember, we can use this expression to see whether or not they fit into a standard form, and we can really just look at the equation or the function and say, nah, the degree is off, it's not fitting the form that we're used to. Let's look at this next one together. In example 2, we're going to be evaluating a linear function. So in August 2000, the Russian submarine Kursk sank to a depth of 300 feet in the Barents Sea. The linear function P of D, right here, is equal to 62.5D plus 2,117. It can be used to find the pressure, pound per foot square, at the depth of D feet below the surface of the water. Before you get kind of confused, because there's a lot of things here that's happening, right? What we need to do is kind of make sure we understand what they're asking, not of us, but what we're given. So we know that this is some function that we're going to have to use. We recognize that there's P of D, D is here. They told us D in feet is the surface below, so it's how far down we go. So D is the amount of feet we go down below. P of D refers to the pressure. And we don't have to worry about the units, pounds per foot square. That's something you might think more about in physics, which is awesome if you understand it. But even if you don't fully understand the concepts here, you can press through the problem. So find the pressure at depth 350 feet. Well, the depth, D, 350, the pressure, P of D, we're going to find it by plugging in 350 for D and solving for P of D. So this is basically what we're doing. We're plugging in 350 in for D into this part and into the equation. And so we figure out the pressure at this time. And if we calculate it, multiplying 62.5 times 350 and then adding 2,117, we get 23,992. And so since they tell us that the units would be pounds per foot squared, we're going to put that right there at the end. Okay, so let's look at this last portion of the question. Let me scroll down a little bit. It says in terms of the 2117 in the function, it represents the atmospheric pressure at the surface of the water. Makes sense, because if I throw a 0 in here, 62.5 goes away, 0 depth, I get at 0, the pressure is 2,117. Makes sense? How many times as great is the pressure at the depth of 350 as the pressure at the surface? So they're just talking about a comparison here. And so I'm just going to divide this number, the pressure at 350, by the pressure at the surface, and I'm going to find that I'm going to get something like, and I'll do this, I'll use a calculator, I'll get 11.3 times as great. Okay, so this next example has us writing in standard form. You guys remember we just talked about standard form as being ax plus by equals c. And then they asked us to go a step further and identify a, b, and c. This is like literal equations. Remember literal equations where you're just moving stuff around? It's almost like a game of shells, but we just got to do it legally. So we're going to do that. So since we know that standard form has the x term rather, and the y term on the right side, we're going to just make sure everything's doing what we need to do, meaning move the x term and the y term to the y side, right? To the, I said right side, to the left side. We need to move this stuff over here. Y'all know what I'm talking about. All right, so I'm going to add 2x to both sides here, and this is moving the x term. When I do that, I get 2x plus y equals 3. And then I have to ask myself, it looks like the right form, but is a, b, and c all integers? And technically there's a 1 here. So yes, a, b, and c are all integers, and finally is a positive? Yes, it is. And therefore I can say that a is equal to 2, b is equal to 1, and c is equal to 3. And I'm confident that I've done the job. Let's go ahead and take a look at, not that. Let's go ahead and take a look at this. Let's try to figure out how we can make all of this integers. So we want the x and y over to both sides, over to one side, over to the left side. So I'm going to subtract the y. Let's just do that. Doesn't feel great because we got this fraction that sometimes makes us feel uncomfortable, but we're tough. Equals -2. So what I'm going to do now is get rid of the fraction by using the power of algebra, which means what I do to one side, I could do to the other. Doesn't matter what I do, I can do it. So when I multiply this side by 5 and this side by 5, what I end up with, let me go ahead and write down here, is the 5 cancels out here. I get -3x. 5 times -3 is going to be -15y, which is equal to -10. Now, this is almost great. However, we don't want all this negative. We don't want this guy to be negative. These guys can be negative, fine. This guy, we don't. So to undo negativity, we can multiply both sides by -1. Again, the power of algebra allows us to do the same thing. What you do to one side, to do to the other once it's the same. Boom, boom. We're going to multiply through. And basically, when you multiply through by -1, everything becomes positive. So remember, we didn't care that these guys were negative. It was just that a value that needed to be positive. So a equals 3, b equals 15, and c is equal to 10. All right? And finally, we need to just do this guy. Remember, we want the a term and the b term, the ax and the bx on one side. We need to get this constant over, and when I do that, I just add 9 to both sides. I get 3x minus 6y is equal to 9, and I'm good. A is equal to 3, b is equal to -6, and c is equal to +9. For this final example, example 4, we're going to use intercepts to graph a line. So here's the equation that we're going to graph, and here's the setup we're going to use. What we're going to do is follow what we talked about earlier. We know that the intercept is merely the value for one function, term when the other term is 0. So the y-intercept here is in yellow, and if I want to calculate the y-intercept, I'm going to go to the x value, and I'm going to put 0 in there. So 3 times 0 minus 4y plus 12 is equal to 0. Now I'm going to solve. So when I solve this, I'm going to move my 12 over to the other side, right? And then I'm going to get -4y is equal to -12. Well, you guys, I'm going to get this out of the way. You guys know that right now all I'm going to do is divide both sides by -4, and I'm going to get a +3. So that's the y-intercept. Let's do the x-intercept similarly. I plug in 0, and now I'm going to solve for x. 3x is equal to, move this 12 over to the other side, -12. Therefore, x is equal to -4. I now have my 2 points. I'm going to plot them and draw my line. And here's our answer.